Okay, here is the explanation of FRQ4. So let's go ahead and read it. It says at time t equals 0, a boiled potato is taken from a pot on a stove and left to cool in a kitchen. The internal temperature of the potato is 91 degrees Celsius at time equals 0. So right away, I am going to underline that because that's going to be important. And the internal temperature of the potato is greater than 27 degrees Celsius for all times greater than 0. The internal temperature of the potato at time t minutes can be modeled by the function h that satisfies this differential equation. d of h dt equals negative 1/4 times h minus 27, where h of t is measured in degrees Celsius and h of 0 is 91. So this equation right here is your rate of change of h with respect to t. Okay, so let's look here. Part A says, write an equation for the tangent line to the graph of h at time equals 0. Use this equation to approximate the internal temperature of the potato at time equals 3. So what do we need to write the equation of a tangent line? We need slope and our point. Okay, so our point is at time equals 0. So that is going to be the point 0, comma, we're given right here, what is h of 0? 91. And our slope is dh dt at when time equals 0, and our temperature is 91. So to evaluate and find our slope, we're going to evaluate the rate of change of the temperature with respect to time. And h is 91. So this will give us our slope at time equals 0. So when we plug in 91, we subtract and multiply by negative 1/4. Our slope is negative 16. Okay, so once we have that, we get y minus 91 equals negative 16, and we're in terms of t minus 0. And so when I move that over, I get y equals negative 16t plus 91. So that's our tangent line of our function at time equals 0. We want to use this to estimate the internal temperature of the potato after 3 minutes. So we're just going to plug in 3. And our time there is approximately 43 degrees Celsius. Okay, part B is asking us to use the second derivative of h to determine whether your answer in part A is an underestimate or an overestimate of the internal temperature of the potato at time equals 3. Okay, so think about the things that your second derivative tells us about a function. Remember, it tells us about concavity, whether it's concave up or concave down. So let's take a look at our second derivative. So if we have dh dt equals negative 1/4 times h minus 27, and we take the derivative of both sides, we get our second derivative of h with respect to time is going to equal our negative 1/4 times our derivative of h with respect to time. Okay, we know what our derivative of the temperature with respect to time, that was given. And if I multiply this, this is my second derivative. So my rate of change of my rate of change of the temperature, the internal temperature of our potato for all values for T greater than 0, and our internal temperature is also greater than 27 degrees Celsius this entire time. So when looking at this, 1 over 16 times h minus 27, since our h value is always greater than 27, the value in here is always positive, times 1/16, meaning our second derivative is always positive. So think about what that tells us about our function h of t. It tells us that if our second derivative is always positive, that must mean that it is concave up. So since our second derivative is greater than 0, then the function for the internal temperature of the potato that represents that internal temperature is concave up. For our values greater than 0. And the answer in part A must be an underestimate. Okay, how do we know that? Well, we know that our temperature comes out of taken from a pot on the stove at 91 degrees Celsius. So we know that it's decreasing, right? We know it's going down. And for this, our second derivative, it's positive, meaning that that is decreasing concave up. So if you think about your tangent line is right here. So if you're using that tangent line in part A to estimate this value on the graph, you're getting that value, which you can see is below. So that's why it ends up being an underestimate of the actual value. Okay, so let's take a look at part C. It says for T less than 10, an alternate model for the internal temperature of the potato at time T minutes is the function G that satisfies that differential equation dg dt. So remember, it's again giving you the rate of change with respect to time of the internal temperature of the potato. Okay, so again, anytime you see dg dt and the other one dh dt, remember that you're given the derivative, okay? So when you're being asked to find the model, how do we work backwards? We need to integrate. So it says that it's still at time equals 0, temperature still 91 degrees Celsius. We want to find an expression for g of t, okay? So we are going to find that particular solution here that satisfies the given of g of 0 equals 91, okay? So how do we do that? How do we go from the derivative back to the function? We integrate, okay? To integrate, you need to separate your variables and get them on the right side. If you notice in the rubric, it will tell you no separation of variables, you get a 0 out of 5, no matter what. No matter if your answer's correct, no matter if you labeled, no matter if everything else is right, you don't show that separation of variables, they will not give you credit for the problem, okay? So what does that mean? We want to get our g's over with the change in g. So I'm going to do that by dividing, okay? And that's going to equal -1 dt, and we can even move this up and write it as g minus 27 to the -2/3. You don't have to yet, but you can. Now that we have our separation of variables, we're good to go. So if we do everything correctly, you should get a 5 out of 5 on this part of the problem, okay? So to work backwards, we are going to integrate, and I'm going to integrate. Notice I kicked that -1 out front. I'm just going to leave that there. On the left-hand side, technically, you have g minus 27 as your inside function, so we do need to use u substitution. I know the derivative of that is 1, so, but I'll still go ahead and show you that. So if I let u equal g minus 27 du dg equals 1, du equals dg, and now I can plug that in order to integrate. Okay, so I add 1 to my exponent, divide by 1/3, it's the same thing as multiplying by 3. The integral of -1 dt is just a -t plus c. And then we can plug in our u value back in. So we get 3 g minus 27 raised to the 1/3 power. And we want to find our particular solution that satisfies the given information, which is at time t equals 0, the internal temperature of the potato is 91 degrees Celsius. Okay, so let's plug in those values. And I'll subtract 91 minus 27, which gives us 64. The cube root of 64 is 4. And we get C equals 12. So we are still looking to find our model for G. So when I plug that in, I have 3 right here, 3 times G minus 27 to the 1/3 equals -t plus 12. I need to solve for G to get our model for G. I'm going to divide everything by 3. And to undo the cube root, I'm going to cube both sides, which gives me G minus 27 equals -1/3 t plus 4 cubed. And then I'm going to add 27. So my function G that satisfies the initial condition will equal -1/3 t plus 4 quantity cubed plus 27. And we're going to use that model to evaluate the temperature at 3 minutes by plugging in 3 for t, which gives us 54 degrees Celsius.